Today we're turning this antique portable TV into a portable home theater. If you caught my part showcase, you saw a 5-foot bench littered with 30 products that were to be stuffed in less than a square foot of this antique TV. Was it over ambitious? Did I just get rolled on by my own logo? Of course it was over ambitious, it's a ManicMod. Welcome back to the channel, family. Today I'm going to share the entire build process of my retrofit that I will dub the PiJamTV 2.1. I'm going to explain why it took 3 months to build and produce this mod. Nope, I'll make that short. Doctor said I got the nerd neck. If this hand's forward, it's numb. Enough about me. Buckle up, enjoy my retrofit journey, hit that thumbs up if you like it, and stay tuned for more. You can't have PiJam without the jams. Just like the planning phase, audio came first. When building, the oversized audio system set the footprint for everything else installed. I selected this Tang band subwoofer because anything else would have fit better. I used its protective cover as a template to mark the corners of the speaker. I played a quick game of connect the dots with a straight edge, which aided my first cut into fresh PVC. After some cleanup work, I opened up the subwoofer's mounting holes by drilling from the back straight through the front panel. I used those same holes to mark the mounting points on the TV. Then mounted the subwoofer with grommets, which, don't worry, will receive a proper grill later. The first component was not a success until I answered the big question.
Will it close, though?
I asked this several times with increasing concern through the build process, but it's too early for failure and she fits like a glove. While halfway close, I marked how far the subwoofer extended to the front of the TV. I knew this entire thing would be shoehorned together, so this line also marked where the main speakers would start. I used the front of the sub to finish my marking and was reminded how poorly a Dremel works for circles, but with some grit, I cleaned that hole right up and dropped the right speaker in. I didn't want to use a hole cutter, afraid of chipping the TV, but it turned out this 64mm saw could have saved me 20 minutes because it was the perfect fit without the hassle on the left side. After the speaker holes were cut, I marked and drilled their mounting points. Like the subwoofer, these were mounted with grommets for vibration control. This concluded the 2.1 speaker installation, and my next priority became fitting the amplifier. When I was testing mini amplifiers, the sound of this Dayton audio paired with the Tang band speakers was second to none. I knew it would be the most difficult to retrofit since it had the largest footprint and of course did not have the pigtailed knobs like the Django. I considered extending the knobs to the front panel but was ultimately afraid of introducing noise. I also didn't like the thought of mounting it to the subwoofer, so I prepared to install through the top right side of the TV. To do this, I marked a line where the amplifier would pass through the battery compartment of the TV, and after some cleanup efforts, I was ready to slide the amplifier into place. From there, I marked and pre-drilled my first knob hole that would dictate the horizontal position. That hole and the faceplate became my template for the rest of the knobs. These holes were opened up according to demand, and the finished product was looking good. These mounting posts would be replaced later, and for now I just had to ask.
It's gonna close, right? Yes. Yeah, for now.
Yeah, for now. Do you hear that confidence? Maybe he's right. Either way, we're getting pie face now. Pie preparations are underway. Now that I knew I was not going to use the TV's original knobs, I removed their frame for modification. This frame was cut in order to retain the TV's internal support. I absolutely had to keep the tuning dial, which will be later illuminated, and after a quick cleanup, I moved on to mounting the display. No fancy prep work here. I slapped the IPS screen into the TV's visor. Mounting this way ensured I was maximizing my interior space. My friend Ralph 3D printed a bezel that went in front of the screen, and I temporarily adhered them together to determine my mounting points. These points were at the extremities of the interior frame, but each of the 4 screws went in without any concern. Here's where I'll assemble my stack of pie goods, but first I had to solder on a power button connector to the main board. I'm not the best at soldering, but I didn't burn my pie. One quick test later, I was on to building my pie scraper. Above the pie is my DAC, which will be elevated later, and above that is my SSD for Raspberry Pi OS. But this isn't a one-trick pony. That microSD card extension is for my primary OS. When the card is inserted, the TV becomes a high-definition music player thanks to Mood. So to switch between operating systems, this card had to be made accessible. I used a piece of a bracket to guide the Dremel through the TV's interior. Yes, I'm blocking your view, but also yes, the plan worked. The card reader adhered to the bottom of the TV and works accordingly. I'm not covering operating systems in this video, but if you have any questions, leave them below and I'll try to sound like I know what I'm talking about. There's also a like button there if you want to give it a little tickle for me. Alright, time to switch it up. To pull this build off, I needed to containerize as many circuits as I could. For example, I plan to install my speaker switches on the left side of the top. These switches will land right by the amp and allow me to interrupt the internal speakers when external ones are connected or if troubleshooting is required. After the holes were opened, the switches were popped in. One side of each switch was connected to the positive of the amplifier and the other side to the positive of the speaker. I repeated this 3 times, 2 for the mains on the top half of the TV and again for the subwoofer on the bottom half. For this, the output wires were pigtailed to a test connector along with the power input for the switch's LEDs. At this point, it was time for a sound test, and just look at that little sub doing its thing. The switches earned their keep. I killed the mains to chase down a rogue vibration. Turns out one screw post got a little too cozy with the subwoofer, which the sub clearly was trying to escape from, but that didn't stop me from celebrating good vibrations. The PiJamTV was officially 2.1. This is an RCA relay that would ensure I had a secondary RCA input to the Dayton audio amplifier. It was disassembled and wrapped in EMI shielding in preparation of install. And here is that relay installed, the output going to the amplifier along the new secondary input. The primary audio input as well as the power input for this relay would be pigtailed to the bottom half of the TV, and its switch would live among the power and brightness switches I will install next. The Pi power button would connect directly to the header we added in the last section, and the brightness would connect to the screen. Each of these momentary buttons were pre-wired, the LED power was pigtailed, and respective connectors were added for the switches. Once installed and tightened, a matching connector was added for the brightness switch, the power button was connected, and this is our final product. ManicMods is totally modular, bro. Yeah, it don't matter if it's a car stereo wiring harness. Damn. My recent standing desk install. Damn. The backside of this TV. Damn. It's just how I do things. And for this I/O plate, there was really no other options. I started by marking the battery pack that would sit on the back of the original battery cover. A center line guided the pre-drilling before I enlarged the holes, and at this point things were looking good, except I entirely forgot about the power port. This was a blessing in disguise. I pulled the HDMI in favor of the power port, and the HDMI will make its way back into the build later. For now, I had some terminations to make. These 6 wires are from the external battery connector and were crimped onto an internal connector. For the speakers, a 6-pin Molex extension was cut before ring terminals were soldered onto its leads, and these ring terminals were fastened to the speaker output posts. These output posts would now route through the connector to another one connected to the amplifier directly. After determining the length, more ring terminals were added, coffee was had, and I completed the output section. But I don't want to forget about the power again. Business as usual here, found some good connectors, cut to length, and soldered my battery adapter. This adapter takes 3 different voltages from the battery for internal use, and it works as good as it looks. Not everything has to be so complex, as long as it's modular. I used Velcro to adhere the battery to the rear cover for serviceability. External connections not only extend a functionality, but like modular connections, they make troubleshooting easier. And if you build things like I do, troubleshooting isn't a possibility, it's a guarantee. This TV had to have an HDMI output. As mentioned, scrapping this port from the rear I/O was a blessing because now I plan to add it directly above the microSD slot, which reduces cabling. There was no way in hell I was going to Dremel a slot for the HDMI port and elected for a handsaw instead. After the slot was made, I used the HDMI coupler to mark and pre-drill the mounting holes. I added one of my final pieces of acoustic mat and mounted the port with grommets like I did for the speakers. This HDMI coupler was then extended to the Pi 5 with a flat HDMI ribbon cable for tidy integration. My next step was making the USB SSD accessible from the bottom of the TV. I marked the outline of my solid-state drive that will sit here, as well as my mounting point to the subwoofer here. The corners of the outline were drilled to determine the cuts needed from the bottom of the TV. It wasn't the easiest or prettiest cut, but some Velcro solved for both aesthetics and accessibility. Once that piece was cut, I removed the subwoofer and used these shallow screws to fasten the USB port. Bias, please. Just Just so you know how that title is supposed to sound. This is perhaps the most manic part of my mod, largely because I had already selected an LED strip but decided it wasn't as cool as a music activated strip I had on hand. And to sure it wasn't still too easy, I wanted a specific pattern which placed the center of the strip in front to ensure a beat rolled from the front to the back of the TV. Welcome back to ManicMods, where the possible is pushed to impossible and then dragged across the finish line. To achieve my design, I cut the LED strip into 5 segments, then bridged the power contacts of the 2 mid sections and the 2 rear sections. While the segments all shared power, I had to ensure the data out of one segment ran to the data in of the next intended segment. After pre-wiring these strips, the middle was put front and center. Its input and output would connect to the middle segments, which in turn connected to the rear segments. Since these strips were so close to the subwoofer grill, I worried their light output would be suppressed. A new grill was snipped from a broiling rack before I adhered the 5 segments. And after a quick test, I laughed like a maniac and mounted the new subwoofer grill before final wiring. Here is the power and data wires for the rear segments that travel to the mid sections, which connect to the front section, and here is the controller that was opened to install onto the bottom of the TV. It delivers 5 volts to all the strips and the data to the first segment in the rear. You've seen me solder enough, so here is the final product with only the 5 volt input left to connect. We're almost done with the build, fam. I appreciate you sticking around. Today we're finishing up the bottom wiring. Below the Pi power and brightness momentary buttons, the bias and RCA switches were added, maintaining a nice continuity with the original labels, contrast, and selector. I tested and shortened the LED strip that would be used for the tuner dial backlight. To any friends named George that pick on my OCD, I present this unmodified USB power connection from the strip directly to the Pi. What? The whole thing can't be simple. With that connected, the backlight dial is officially a power indicator for the Raspberry Pi, but it's too early to celebrate. We have a termination block to add here. I marked the holes to correspond with the interior mounting location on this ledge. After drilling these mounting points, the termination block was adhered to a thin plastic base that was also pre-drilled and used to fasten the buck converter. What is a buck converter? Well, it takes 12 volts, 2.5 amps and converts it to 5 volts, 5 amps for the Raspberry Pi 5 to ensure it has adequate power. With the mounting block in place, I rounded up all of the positives of the 12 volt switch LEDs and added a yellow ring terminal to them. These will all connect to the same 12 volt rail as the buck converter. These LEDs will not all be on by default and will be negative switching. The exception is the power LED, and as such, it's directly connected to the ground, along with one side of each the bias and RCA relay switches. This green wire is the 5 volt bias controller input, which was soldered onto a red ring terminal, and the switch ground would come from the front bias switch. As such, the last lead here is the switch ground from the bias switch for the speaker switch LEDs on top of the TV. Finally, the RCA switch's ground output was connected to its own LED and a ring terminal for the RCA relay. Did I say finally? Better not forget about the subwoofer. Here is the progress on the termination block as well as the pinout. And here is another quick power on test. The Pi powers on along with the dial light, and shortly after testing the bias switch, the display comes to life. Display comes to life. There it is. Now all we have to do is add a leaded plug to the termination block. I selected this connector, which will sit in one of the ingresses of the subwoofer. Before I do,
here's where I keep assorted lengths of wire.
Whoa. Okay, cut that out. Where's my coffee? Ah, there's my coffee. And these are my assorted lengths of wires ready for duty. Cheers to us, it's time to add the connector. One end of the wires would terminate to the block, and once the coffee kicked in, I sped through adding them to the plug to complete the bottom of the TV. We still got to finish the top, but we're about to seal a deal. It's time to wrap up this retrofit. The mods are mounted, the chaos is harnessed, and the glow is flowing, but none of it matters until it's closing time. Let's get it. This 1TB SSD contains a copy of my uncompressed music collection and is finally home in the underbelly of the PiJamTV. Next to it, I installed a modified silicone foot for vibration control. On the top of the TV, a hole was cut to secure a small rig Hawk mount, which may or may not be used for a Pico projector in the future. This TV already had the DNA of a cyberdeck, so of course it needed a proper keyboard and trackpad. tucked neatly under the handle like it was always meant to be there. But nothing in this TV will work if I don't connect the power sources. I measured and cut a DC connector for the Dayton audio amplifier, and this was pinned to the 24-volt rail of the battery interface. I cut, reworked, and extended my original 4-pin plug that went to the bottom of the TV for the bias and subwoofer. New red, yellow, and black wires were cut for respective 5-volt, 12-volt, and ground rails from my battery. Hearing these little pins pushed into place never gets old. I was now ready to add my internal mid connector that would bridge the bottom and the top half of the TV, but instead opted to make an extension cable first for lab testing. Full speed ahead, color codes intact, I wrapped this up nicely and could return to my regular scheduled program. At this time, I pinned my last connector before some continuity testing and a final power on test.
Boom, boom, boom. Mood, on mood. There we go.
After some more coffee, I was ready for final assembly. Gone is my extension cable, my rear cover put aside, and together the pieces went. But not so fast. I had to route an accessory USB and Ethernet to the rear through a hole I previously opened. And together the pieces went again before the shell was buttoned up. And don't you worry about that hole from the original accessory plate, it'll be covered in an upcoming video. The battery compartment now housed a ground loop isolator, and it was a tight fit, but it's closing time, damn it, and she snapped together with some good old grit. The game controllers were installed with Velcro on the left side before the battery was installed and connected. This left only the keyboard, which after installation I had to admit,
She's a beast, ladies and gentlemen. What a beast. Beast, beast, beast. Beast.
3 months, 30 plus parts, and at least 30 times I questioned my life choices. But the PiJams I set out to build is built. With real bass, real brains, and more ports than a gaming laptop. Every inch of this build screams ManicMods. And I hope you want to see it in action because that's exactly what's coming next.
This winter, ManicMods brings you.
Hopefully it won't take that long, but I can't do it without you. The future of my channel relies on you sharing my retrofits and fearless modifications. So if you laughed, learned, or enjoyed the production, please share, give this video a like, sound off in the comments below, and stick around because this is only the beginning.
ManicMods is totally modular, bro.